Taking a look at practice question set number 4, numeric response number 1 says a proton collides with a stationary alpha particle. Do you guys know what a proton is? We should. We know what a proton is, right? Although sometimes we forget exactly which is which, the proton, the neutron, whatever. Proton's in the nucleus of the atom. That doesn't really matter here. In the end, all you need is the mass of this, and the mass is on our data sheet. The alpha particle, most of you probably don't know what an alpha particle is. Doesn't really matter. It is the product of a certain type of radioactive decay, and we'll talk a lot more about that in our last unit. But right now, all you need to know is that it has mass and what its mass is. That's on your data sheet as well. It says after the collision, the proton moves at this speed opposite to its initial motion, in direction opposite to its initial motion. The alpha particle moves forward in the same direction that the proton was initially moving. I think the wording of this is tricky. I do. I think it's really tricky, actually. They're saying that whatever direction the proton is moving initially, that's the way the alpha particle is moving final, and that's opposite to the way the proton is moving initial. And there seems like there should be a way easier or way more clear way of stating that than they have in this question. But in the end, that's the way they stated it, so that's what we got to go with. What is the initial speed of the proton? All right, so let's write down some givens here. We're going to call the proton object number 1, and the mass of that, if you look at your data sheet, is 1.67 times 10 to the minus 27 kilograms. The mass of the alpha particle, also on your data sheet, 4 times the mass of a proton, 6.65 times 10 to the minus 27 kilograms. Let's say V1 initial. Do we know what the value of V1 initial is, the proton is, before this collision between these two subatomic things take place? Do we know what its speed is? That's what we're trying to find, isn't it? So let's put a question mark by that one. Do we know what V2I is? The initial velocity of the alpha particle? Yep, 0, right. It says it's a stationary alpha particle, right? Watch those words, right? Stationary, not moving. Know what those mean, because we don't want to get a question wrong just because of that, right? Just because of the definition. What else we got? Well, we got V1F. What's V1F? The velocity of the proton after the collision. 3.35 times 10 to the 6. Yeah. Venture is at 3.35 times 10 to the 6. Okay. So in the end here, let's write down V2F, and then we'll deal with what you just said here. 2.25 times 10 to the 6 meters per second. In the end, one of them has to be negative, one of them has to be positive, right? Doesn't really matter which is which. Since it says the alpha particle moves forward, I'm going to make that positive and this one negative. But again, it's not really a big deal as long as you have them in opposite directions. We know they're in opposite directions because it says the alpha particle moves in the same direction as the proton was initially moving, and the proton is moving opposite to the way that it was initially moving. We probably should have, when we read this question, circled those to draw attention to that so that it clarified it for us, less likely to make that mistake of forgetting the negative later on. All right, now that we have our givens written down, that's what we said over the last couple of days is really the biggest part of this, right? It's the biggest part of it is writing down your givens. Hey, the rest of it is, well, make sure you get your signs right, make sure you do your algebra right, and so on. But this is the hard part of it. Once you get this written down, then a decent grade 11 student would be able to solve this problem, right? Say PI is equal to PF. We say M1 V1I plus what? M1 V1I plus nothing, right? Nothing, 0. In fact, we can leave that term out completely if we want because its value is 0. Equals, they don't stick together, so we're going to say M1 V1F plus M2 V2F. Masses cancel here? No, because they're not the same, right? But you could actually, you might not want to do this because it doesn't really save you much work or much effort, but you could actually cancel the exponents because the masses are both 10 to the minus 27. So 10 to the minus 27 appears in each term, as does 10 to the 6 appears in each term. So you could cancel out the exponents. Okay, I'm not sure that it's useful to do that, but you could if you really wanted to. Save yourself a little bit of work on your calculator, I suppose. I'm not going to do that. 1.67 times 10 to the minus 27 is our mass of the first one. V1I is what we're looking for. Equals 1.67 times 10 to the minus 27 times V1F. What is V1F? 3.35, negative 3.35 times 10 to the 6 plus 6.65 times 10 to the minus 27 times 2.25 times 10 to the 6. Okay, so let's get this number right here. Let's combine it with this number, and then let's divide it by 1.67 times 10 to the minus 27. When we do that, we should get an answer that is 5.61 times 10 to the 6. How do we express that A, B, C, D? A decimal BC times 10 to the, should be A decimal BC times 10 to the positive D. A, B, C, D, my answer is 5, 6, 1, 6. Make sense? Now, sometimes we see a question expressed a little bit differently. Sometimes we see it expressed B times 10 to the W. And we're looking for the value of B, the base there. What would the answer be if I was looking only for the base, B times 10 to the W? 5.61. We'd include the decimal in that one, right? Not here, because we're just looking for the digits. But if it's B times 10 to the W, we're looking for the decimal as well. Okay, good. How many people got that? Like, you might have changed your answer because it was because of the way the question was with the typo and so on, but okay. Good. Okay, let's take a look at number 2 now. It says a clerk working at a local food store is asked to retrieve some empty shopping carts left outside by the shoppers. Each cart has a mass of 20. Clerk places 8 carts which are locked together close to the entrance on a slight incline. The clerk gathers another 12 and pushes them toward the store entrance. Now, listen, all of this stuff that's happened so far doesn't really matter. It doesn't really matter, right? Like, this has nothing to do with the collision per se. Now it starts. It says 8 carts roll towards 12 carts with a speed of 2.3 meters per second. We're going to say Pi is equal to Pf. M1 V1I plus, what's M2 V2I? Oh, well, I guess we don't know yet, do we? M2 V2I equals, what's the final momentum? We do know that. They stop, so the final momentum is 0, yeah. So we're going to say, 8 times 20 is 160. V1I is 2.3, it says. We want to know how fast the 12 carts were moving, or the 240 kilograms were moving. V2I equals 0. This comes over to the other side by subtracting. Divide by 240. V2I ends up being equal to, it's actually negative 1.53. What did we actually solve for? When we solve for, got negative 1.53, we solved for the final velocity. What are they asking for? The final speed. So in other words, they're really only looking for the magnitude of that velocity. Good? Number 2, getting there. 2,100 kilogram van collides with a 1,200 kilogram car that's at rest. They lock together. What was the initial speed of the van? This is like the police officer at an accident investigating the scene, right, to see how fast the van was moving before the collision took place. Was the van speeding or not? M1 is 2,100. V1, let's go M2 is 1,200. Let's say V1I. That's what we're trying to find, isn't it? The initial speed of the van. V2I is what? V2I is, quick, 0. And we're going to say VF, the final velocity here is 4.5 meters per second. It's the two things combined here. Pi is equal to PF. M1 V1I plus 0, because the second object is at rest, equals M total times VF. That's the total mass here, 3,300. So calculate that number on the right-hand side, 3,300 times 4.5, and then let's divide it by 2,100. And for this, we end up getting 7.07. Notice the way they want me to express this. It doesn't say scientific notation. If it doesn't specify scientific notation, then you got to get an answer in standard notation that you can put into there. So if you got like 629,000, I mean, clearly that would be wrong because a van would not be moving that fast. But even in some other context where it's a particle that could be moving that fast, it has to be wrong because 629,000 couldn't fit there without putting it in scientific notation. Okay. 7.07, we just fill that in if this was a test like this. Standard notation. And finally, the last question, the fun one because it's bumper cars. Bumper cars operate on electricity. The more the accelerator pedal is pressed, the more current flows in the system, thus the faster the car travels. X and Y are going to collide head on. X is traveling one way, Y is traveling the other way, east and west. Okay, draw attention to that. If after the collision, car Y is moving at 0.526 to the east, car X is moving which way? We're going to say M1 V1I plus M2 V2I. Unfortunately, it'd be nice if one of them was at rest, because then we could get rid of that term, right? But it's not. Can we cancel out the masses here? Can we cancel out the mass? Can we cancel out anything? No, no. We don't very often see that, right? But we hope for it every time because it saves us a little bit of work. Mass 1 is 125 kilograms. V1I is 2.25. M2 is 161. V2I is negative 1.3. M1 is 125. It's a negative because it's to the west, right? V1F, that's what we're looking for, plus M2, 161 times 0.526. Okay, so get the number on the left-hand side here, get the number right here, and then we take that over by doing what? Subtracting, right. You multiply 161 by 0.526, take it over by subtracting. And when you do that, you end up getting, for V1F, negative 0.102 meters per second, which is 1.02 times 10 negative 1 to the west.